Okay, let's start building this circuit. First, we're just going to put in the 555 timer chip, make sure that's over the gap so that none of the pins are connected in any way. We're also going to take the potentiometer and put that in as well, also making sure no pins are shorted. And that will be the beginning of our input. We'll take from positive to about there, and then we'll take one of the 1000 ohm resistors. And you can see that that's going to the input, one of the outer pins. We can also take from power to pin 8. And also pin 4. Then we can take ground from pin 1 on the chip. And now we will take an output from the center of the rheostat. This is to just give us some room to work with. Now we can take that output to pins 2 and 6. There's pin 6. There's pin 2. And then all that's left is the 100 microfarad capacitor. And being extremely mindful of the polarity, you can see that this one is labeled with negative stripes. And also the positive lead is usually longer. So that's how we know we have the right side. Take that over, and we can take it all the way to ground. Take that over. And then we can take it to ground. Now we also need to take from the 1000 ohm resistor to pin 7. There we go. And that is the 555 timer circuit. Now we just need to take an output from that. That's pin 3. That's just to give us some space. And then making sure on the pins of the relay, which can be found on the data sheet, we put it to the coil. And we need to make sure we go to the correct ground on that as well. And that is the first circuit complete. We just need to attach a power, a jumper which will allow us to supply power, and also a ground. Then we can take a battery with some jumper cables, alligator clips, and we go positive to positive, and negative to negative. And you can hear the relay clicking back and forth. So that means it's working. Now it's time to do the second circuit. Now for this, we're going to use the other positive and negative rails. Now, I did this by turning it upside down and using opposite sides, positive and negative. That just works for me. It might make more sense to use these two positive and negatives in a pair and this positive and negative rail in a pair. Either one works. So to do this, we're just going to take the other positive and we take a 1000 ohm resistor from both of those. Then we take on one side another 1000 ohm resistor to ground on this side, and a variable photoresistor which has a max of about 30,000 ohms. And we'll take that to ground on the other side. And this, when we bridge the gap, will create a Wheatstone bridge that only allows current to flow when they are imbalanced. And this creates it as a darkness sensor. Now we take an output from the side with the photoresistor and take that to the input on the relay. And since this isn't quite long enough, we can just move this over a little bit. Okay, now we take from one side of the photoresistor, or the side of the bridge with the photoresistor, and we'll bring that over here, and then we'll put in a 470 ohm resistor, and that just prevents us from ruining our LEDs. Then we take that, and checking the right pins, we do it to the input for power on the relay. Now we take an LED from both outputs, both the normally closed and normally open. Once again, checking the pins to make sure we get them right. And those can go in the same pin, making sure they're all steadily connected. And then those are now in parallel, basically. Now we just take from those two and do it back to the other side of the bridge. Once again, hook up a place for power and for ground. Now we take another battery with another pair of alligator clips, and once again go positive to positive and negative to negative. And the darkness level is low enough, or the light level is low enough that there's an imbalance and current is flowing. And just to test that, if I cover it up, we can see it get brighter. So now we can connect both of these. We'll take our other battery and hook that up to the positive and negative. And you can see that we have our flasher going. We have the 555 timer doing its timing, and the darkness sensor circuit sensing whether the darkness is there. So if I do this, it gets brighter. And if I were to take a light you can see that the lights stop going, but when I turn it off, they come. I've turned it around so we can see what we're doing here. Since we have the potentiometer in here, we can also vary the speed of the flashing. So if I turn this, the resistance will be reduced, which also reduces the RC time constant of the timer, which is the product of the resistance and the capacitance, and that determines the timing between the pulses of the chip. So if we reduce the resistance, we will also reduce the time. And you can see that our timing has decreased since the resistance has decreased. And we can do this even more. But we probably don't want to do this for long because it's a strain on the relay. And that is a 555 timer connected to a Wheatstone bridge to sense darkness with a relay to create a light flasher.